Okay, in section 5.3, we investigate amortization and sinking funds. So the annuity formulas from the previous section may be used to answer questions involving the amortization of certain types of installment loans. A question of finance here might ask is, how much should the monthly payment be so that a loan is amortized or paid off at the end of the loan? In this section, we'll look at how to determine the size of that periodic payment, R. So the amortization formula is R, which is that periodic payment, is equal to P, the amount borrowed, the present value of that amount, R over M, all over 1 minus 1 plus R over M to the negative MT. Literally, this is the present value of an annuity problem solved for R. So it's identical to the other formula. They've just done the algebra for us. Example 1 is a typical house payment or loan problem. So the Sheltons borrowed $270,000 from a bank to help finance the purchase of a house. The bank charges interest at a rate of 5.4% per year on the unpaid balance, with interest computations made at the end of each month. The Sheltons have agreed to repay the loan in equal monthly installments over 30 years. How much should each payment be if the loan is amortized at the end of the term? So let's go identify all of our variables first. So P is how much we're borrowing and that we'll need to pay back. That's the $270,000. Little r is our interest rate, which we know is 5.4%, so 0.054. T is our time, which in this case is 30 years. And they're making monthly payments, so our conversion period is 12. And now we'll plug into our formula. So we know that our monthly payment is going to be equal to that 270,000 times 0.054 divided by 12, all over 1 minus 1 plus 0.054 divided by 12 to the negative 12 times 30. And we're going to do the same thing here, basically, that we did on the last, on the annuity formulas. We're going to work this in parts the first time just to make sure you're using the calculator correctly. So let's go ahead and figure out the denominator this time. So we're doing all of that first. So 1 minus and then the 1 plus 0.054 divided by 12 instead of parentheses raised to the negative 12 times 30. And if you do that, that denominator comes out to be 0.80138808085. Now, without clearing the calculator, you're going to come in and type in what's in the numerator in a set of parentheses, 0.054 divided by 12 in parentheses, divided by the answer we just got. So we're letting the calculator carry all those digits because it just works better. If you do that, you end up with 0.0056153,079. And then finally, we're going to take that answer and multiply it by the 270,000 that's out front. So times 270,000. And you end up with a monthly payment of $1,516.13. And that's our final answer. So the Sheltons have agreed to a monthly payment of $1,500, right? $1,516.13. And then over the course of the 30 years, they will pay off that $270,000 as a mortgage. Okay, let's try another one, letting you do all the work. So example 2, I'm going to leave the formula on the board for just a minute. Example 2 tells us the sum of $50,000 is to be repaid over a 5-year period through equal installments made at the end of each year. So maybe this is a short-term loan. If an interest rate of 8% per year is charged on the unpaid balance, and interest calculations are made at the end of each year, determine the size of each installment so that the loan is amortized at the end of 5 years. So we know that P is that $50,000 that we're borrowing. We know that, again, we're making monthly payments. Double checking that. Made at the end of each year, no. So we're not making monthly payments, we're making annual payments. So only once a year we're making a payment up. So these are going to be pretty large payments to pay off $50,000 at just one payment a year. We know that T is equal to 5 and our interest rate was equal to 0.08. We're plugging it back into this to figure out how much we're going to pay each year. So 50,000. Then we have our 0.08 divided by 1, all over 1 minus 1 plus 0.08 divided by 1 to the negative 1 times the 5 years. Okay, go ahead and run that through your calculator. Let's see what you get. So I calculate the answer is $12,522.82. So $12,522.82. So basically, at the end of each year, you're going to pay $12,000 on this loan, and after 5 years, you will have paid off that $50,000. So